Let's start with the first lab, the lab heartbeat. To complete this lab, you have to open the vhdl code where you find insert your code here of the following files. On the folder to do, open the heartbeat file .vhd and dia0 heartbeat.vhd. This is the top level, and that is a component to instantiate in the top level. You have to implement in the component an entity that toggle a single bit output with a programmable toggle and with the toggle rate that shall be clock frequency divided by an programmable heartbeat divider plus 1. Then simulate your code and lay out your code on Altera Cyclone 3. Let's see what should be the instantiation of your component. You have to select between two different toggle rates selected by the dip switch and connect the toggling output on the first for LED and the second for LED. Remember that board clock is 50 MHz. In this case, in the first for LED, we have to connect the heartbeat, straight heartbeat, and the second for the 1, 2, 3, 4 LED, we have to connect not output. The mux shall be selected with dip switch 9. Okay, let's see how to implement our counter. We have the entity with clock reset, input module, and output bit. We need an internal 32-bit register, that is our counter, and internal toggling bit. Then we have to implement our toggling bit on a process where the counter is reset on reset low. Then we have to count plus 1 until counter reach the module, the programmed module. When the counter reach the module, counter is reset and the bit toggle. Next, we have to assign the internal toggling bit to the output. Let's see how to implement our FPGA. DL0 heartbeat is the top level of the board, of this board. So let's see briefly what are all the signals. We have the input clock, the button, the 3 push button, 1, 2, 3, then the input switch, 10 switch, 0 to 9, the 7 segment display, 1, 2, 3, 4, 0, 1, 2, 3, 10 LED, 0 to 9, the UART, the SDRAM interface, the SDRAM is this one, the flash interface, and this is the flash. The LCD not mounted in this board, the SD card interface, this one, the PS2 interface, this one, the VGA interface, and the GPIO interface, 1 and 2. In this design, all unused pins are set to a value. For the RAM, we set the control active low to high, so the RAM is unselected. And we set to tri-states the data bus. Same for the flash. Don't care for the LCD because it is not mounted. Same thing for SD flash, SD card. Set to tri-states the PS2 port, 0 the VGA, and set to tri-states the GPIO. So let's see how to implement our design. This is the component defined here. So component, earth bit, and so on. Just copy and paste here. Then clock reset, defined as wire, because these are wire connection. The earth bit divider, and we connect the reset on the button 0. So when we push this button, the design is reset. Input 50 MHz clock to clock. The first for LED on the straight earth bit, and the second for LED on the inverted earth bit. Then the 7 segment, the first 2 on, the second 2 off, and the dot point of the LED to the earth bit and not earth bit. The max, this one connected to switch 9. Here's this. So when the switch is off or 0, we select 1 second toggling. When the switch, this one, is 1, we select half second toggling. The earth bit is this one, and this is connected here. Okay, let's simulate the earth bit design.